Yes, hello, welcome to the second episode of the second rundown of devcom tutorials. A wonderful evening if you're watching this right now, or a wonderful whatever it is, should you be watching the recording of this. Welcome to episode 2, as I just said, and we're currently taking a look at Unreal Engine. We've done this before, but right now we're looking at it for people who basically have never used Unreal before and just want to have a few pointers where to get started, which buttons to click first, and how to tame the editor, and how to get the very first things done. And last week, we started out looking at the editor itself, how we can use the editor, which is what, where to click, and we started building, well, a piece of a first level. We're not building a complete level here because that will take way too long, but just building a small piece that, well, it pretends to be a level. And we took a look at, if you're the developer, you're not the artist, what can you do to do the first, or even if you're the level designer, what can you do to do your first block outs of your level, to put first things into a completely empty map, to eventually have it become your level. And today we'll be looking a bit more at this, and we'll be talking, as promised, a bit more about the difference of volume brushes, of BSP brushes, in a comparison with actual static meshes. What is what, and why is there a difference, and what's the difference, and what can we do with it, and especially how can we use the BSP brushes for prototyping, for blocking out the level, and to do stuff. So we're going to be looking a bit more at this. And we're also doing our first code without coding. Yes, we will be using blueprints to do a bit magic in the level. So the first things move, like a door. Last time we have, you can see it down. Where is it? It's down there. You can see it pretty much exactly there. We built a door, and I was corrected. This is not actually a door. This is more of a doorway. This is the hole in the wall where a door is supposed to be. And this is what we're going to be doing today. Excuse me. I need my throat lubrication, which I have handy here, which I'll be using throughout the whole evening. And we'll be building a small door, and we will see how using blueprints, so without any really typing of code, and those of you who know code will see that it's quite similar. You can do pretty much everything in blueprints you can do with writing lines of code, which is because blueprints basically you are coding. It just doesn't feel like it. But this is something we'll definitely we'll be taking a look at today. Maybe if you guys want next week, we could do a quick demo, a quick example of how this would be done if you've done it in C++. But then again, if you want to see C++ stuff in Unreal, I suggest you watch the first season of the Unreal tutorials, because there we pretty much did nothing else but C++ in Unreal. Yes, and tonight we'll be looking a bit more of, well, the getting started stuff. How to put a door into our level, how to make it move, and static meshes, and all that nitty gritty. So, let's get started, shall we? Yeah, Unreal Engine for absolute first timers. Welcome back to the other side of the intro. And again, hi, in case you've just, zapped in or something. So yeah, I just summarized what we did last week. So I would say we just get started and dive into the action. So let me see that you can actually see what I'm seeing. So, well, you shall see. This is exactly where we left off last time, because this is exactly we built just let's see what we did here. Been on my way in different programs, so need to get used to the movement style. This was our first attempt of building a box. Let's take a quick look at this. Oh, and even before this, we took a look at, well, how to move stuff. You know, you can click and move around. Watch the VOD or eventually the recording on YouTube. So there's our static meshes, which we'll be taking a closer look at a bit later today, and we can move them around and do all neat stuff with them. And then we thought, okay, let's build our first room. And a room is basically nothing else but a box. So we started making up these separate shapes, which are also BSP brushes, volume brushes. You get them. Let me just move them out a bit so we can, like an explosion, an exploding diagram. Hold on a second. Need my lubrication. Because that throat really wants it. So down here, this is we cleaned up the whole layout a bit. Maybe you have it different. So this is how I have my layout. Last time we took a look at how can you set up the layout of the editor so it suits your needs or your workflow, whatever you do best. So yours by now might look completely different. You might have left it at default, or maybe you, just to follow up, did it the same way I did. So down here, this is, let me open this step. This is place actors. This is one of the windows. If you don't have this, if for whatever reason this should be gone, like so, it's not there, it's nowhere to be found, you can click on a window, and there is the place actors window option, and we just click this, and for me now it opens where I closed it. For you it might open up, I don't know, someplace else, or if I could get it to maybe even just as a floating window, or maybe it opens here at this side or whatever. And you can just really drag and drop this way you want. You can grab this tab here, and if you don't see the tab up here, if it looks like this, you will have this little yellow triangle here that, even not sure how good you can see this in the stream, but this it gets a bit brighter when you hover with your mouse over it. So just click this and it will reveal the actual tab, and then you can grab the tab and drag this thing around, and you see a preview where this is going to snap if you let go, or sometimes you can even have it as a floating window. And if you have a multi-monitor setup, you can put all the panels and all the windows and all the tools, you can put them on separate monitors and have only the main scene view on your main monitor and have all the tools around. So really use all the screen real estate you have. Right now, right here, I only have one screen because this is the one I'm capturing for the stream, and so I want this down here. So I just drag it there that it snaps, and I adjust the size to what I wanted. So this is the place actors window. Let me just hide this tab so it looks a bit more neat. And this is the one we need. And you have quite a lot of options here. And we'll also be looking at like lights. We don't need cinematic for now. Visual effects, we don't need now as well. Those are a bit more advanced, like sky atmosphere, where you have scattering of light and fog, and how the further something gets away, the light gets, shifted and stuff. Post-processing, like if you want to have some post-process effects, like, I don't know, a bloom or a blur or whatever you want. But these don't do things just on their own. There's a bit more stuff that's needed, so we don't need these right now. The most important thing for us right now is the geometry category, because this is where we got these from. Because we have a box, we have a cone, is a cylinder, a curved stair, or whatever we want. Like, just drag the cylinder right here into the scene, and this doesn't look really, this doesn't look much cylindrical right now. It looks more like, what's that? Is that an octagon? Yeah, looks like an octagon. Also, hexagons are the bestagons. So there's with all these brushes, there's several parameters you can set. Like for this one over here in the brush settings category, we have additive or subtractive. That is something we took a look at last week. Something we used. This is how we created. Let me see if I can get them. Oh, I need to lock my mouse here so I can move a bit around better. This is how we got the hole for the window or the door, because this used to be one flat square, exactly like this one. And then we were like, okay, we need a hole for a door, or we need a hole for the window. So we created another shape of the same type, and you know what? Let's just demonstrate this. Yeah, let's push the subtraction thing a minute back. Let's first check out the options we have for this thing, the other ones, and where they are. Yeah, here they are. Sometimes you need to scroll a bit and see, oh, there's other options. What's this? Do we need this? Not right now. So this is what we want. We try out the subtraction thing a bit later, just a minute or two. And for now we have brush type, which is basically all the geometry types you can select here, like box, cone, cylinder. You find them here. You can just say, yeah, you know what? I wanted a cylinder builder. What's that? There's some fancy stuff you can toy around with. If you want to know more details about these, just check the documentation. This is all in there. So for now, we have a cylinder, which is perfectly fine. This is exactly what we wanted. And somehow I closed the settings. So let me click this again so I have the proper settings. And here we can set the size. We can make it bigger on the inside. No, we can make this bigger on the Z-axis. You can slide around with your mouse and just move the value, or you can just put something in there like, I want this to be 3 meters wide, because what you enter here, this number is in Unreal units. And it's kind of it's defined like 1 Unreal unit equals 1 centimeter in real life. So if you make something 300 units wide, that gives you 3 meters. Because we already have, like when we have in here in this box, we have our player start, and when you use the default first person mechanics of Unreal, because it really can't deny where it's coming from. You have all the scaling and all the feeling of sizes and everything. It's leveled out so that this actually, it looks like it's really kind of about 3 meters. So this is by definition 1 Unreal unit is 1 centimeter. So the 300 that I just destroyed here, let's put this back in there, just gives us about 3 meter width. So also make this 3 meter on the outer radius, because why not? Well, this is a bit big, so let's just move this out a bit. I'll move my camera a bit more. So, and yeah, you see there's some inner radius here that is disabled. We can't go into this inner radius, which is because we don't have the hollow thing set, because we can set the hollow. And then you see there's already a hole in there. The hollow was a bit more of use when we tried to build our room, because we built the room basically out of a simple square, a simple block, and then we made it hollow. So there's this hollow setting has different effects on different geometries. Like if we drag another box in here, you can see this is a simple box. If I move the camera inside the box, nothing happens and kind of vanishes. I don't see the inside walls, because in 3D, you don't always have an inside. And because this box is supposed to be solid. So there really is no inside. So this is why when I move the camera in here, why I don't see anything, because there really isn't. It's a bit weird, it's a bit complicated, and this would be a topic completely on its own. So for now, we'll just be accepting, okay, when we clip into this box, of course, we don't see anything, because it doesn't have any inside walls. Because to have inside walls, it needed to be, right, you guessed it, hollow. So let's scroll down. We have it still selected, I think. And let's enable the hollow for our cube. And you can see all of a sudden we do have the walls. We have 6 walls, 4 on the side, 1 ceiling and 1 floor of our box. And we can also move out again. And we can see, okay, now we don't just have a cube. Now we have a cube-shaped room because we enabled the hollow. So this has a different result, because we also just checked the hollow for our cylinder here, which again still doesn't look all that cylindrical, but I'm coming to this. So yeah, just try the option out and see if it works for you. Maybe you just wanted this actually to be hollow as this cube is, because you wanted to make a round room or something. Then either you have to play around with the cube and make the cube into the shape you want and have it hollow, or you could just create another of these cylinders. Let's make a floor, for example, because we can see this when we're looking from top down. Again, a reminder, we did this last time. When you want to duplicate something, when you want to duplicate an object, just click on it so it's selected, so you could move it around. And now, if you do move it around, but while holding the Alt key on your keyboard, and now you drag it around, you're not moving the original, you're dragging a copy, a clone of it around, and we could just disable the hollow here, and we could make it, I think this was that. Yeah, we could just make this a bit flat and then move it down here. And there we got our floor. Looks like a well now. This pretty much looks like a well. You could do, I don't know, you could make a ring sequel out of this or something. So yeah, same option, different effects. Needs you to do things a bit differently if you want it to be this actually a hollow room. Also, you can set the thickness. Let's go into the box again, and all I'm changing is, again, this is not the box selected. This is the box selected, right? This is without hollow. This is with the hollow option enabled, and then you got the wall thickness. Wow, and that throat really is in a bad mood today. So you also got the wall thickness. And when I start moving this around, okay, I was about nothing happens. It happens when you let go of the mouse. You see, the thicker I make the walls, the smaller the room starts to look like on the inside. Because, yeah, of course, because the walls get thicker. See? You can see the wireframes. You can see the wireframes. This is the outer edge of our cube, and this is the inner one. And when I'm changing these, you can see the wireframes going in and out. Of course, it can't be smaller than 0, obviously. So you can also set how thick your walls you want to have of the room you're building, or in case of this cylinder that still looks more like a well, you could also set the inner radius, and it will have pretty much the very same effect, only that this thing is missing the upper and lower, the floor and the ceiling like in our box, but the inner radius thing kind of pretty much works the same. You also have, and this is where the cylinder actually might be able to become a cylinder or a hexagon. Because if you say, okay, this is an octagon, 8 sides is pretty neat, but I can't have multiple of these because, let me delete this cube, it's a bit in the way. Let's say we have multiple of these like there's one and there's another. Let me see that I get this neatly aligned, and again, you see this is just dragging it out while holding the Alt key to create a clone of this object. A perfect clone. So you just have multiple of these without. You also can, of course, you can do Control C and then Control V to paste it in, and then move this thing around. If this is if this is how you work, and I usually actually do work like this. If you prefer this is perfectly fine. You can absolutely do this. But if you want to, I don't know, save yourself 2 button presses on the keyboard and maybe a second of time, and if you do this 1,000 times, you've saved 1,000 seconds, which is not almost a day, but well, you're getting there. Just hold the Alt key and then drag this around. And while you're holding the Alt key, as long as you're still holding the Alt key, whenever you let go of the mouse and you drag this around, you're not creating another copy. You're still moving your one copy around, and only if you let go of the Alt key and then repress the Alt key, only then you will drag off another copy of this. So let's throw those away, and maybe even this one. Yeah, so we now got these octagons, and if you put them neatly side by side, you see you have a square hole. So octagons are not really suited for perfect tiling. Like a square, maybe you can put as many squares by each other, and there's no gaps. But here we have a square gap if we try those octagons. So let's grab them and let's make this a hexagon, which you can just do by changing the number of sides from 8 to 6. And we do this with our floor as well, just to have it neat and tidy. And if I then drag some copies of my hexagon here, okay, this is a bit harder to align now, because I have to align it on this side. Yeah, well, you get the point. And accidentally, I made another copy, which is not that much of a problem. We just use this. We just move this around and put this here. Well, you get the picture. So what I try to getting at is you can also set the number of faces you want to have. And now if you want to be your cylinder an actual cylinder and not just a hexagon or anything, let's remove this floor. First off, let's also disable the hollow option. And then let's set the sides to, I don't know, 36. 36 sides, and see, this looks pretty round already. And if we now give this a bit more size on the Z-axis, like, I don't know, let's make this 3 times as high, which would be 900. See, this looks like a cylinder. This looks neat, doesn't it? But it's not textured. It's having the totally default checker mark texture that basically tells us you have no texture at all. So there's 2 ways of dealing with texturing with your BSP brushes, your geometry volume brushes. We can go into the materials folder here. And we have brick clay. These look pretty neat. Well, you just drag and drop. You just navigate to the material you want to use. And then you just drag this on top of the surface you want to texture. And this does not look as nice as I was hoping for. Because we're too far away. We need to close in. Now this looks nice. We just were too far away. This is a pretty fine-grained, detailed texture. Let's see if we maybe have something larger. That's just a bit more visible from further away. But you get the point. You just drag whatever. What's this? Basic floor. Yeah, basic. That says it. You just drag your material onto the face of your volume brush. that you want to texture. But then you see it's really only this face. And I want to say, okay, I want to have the side of my cylinder. Of course, this needs to be textured as well. So you start dragging your material onto it and you see, oh, that's only this one little strip there, which is because all these, we said we wanted to have 36 sides of our cylinder. So of course, this is 36 different separate sides, and you have to texture them. You have to drag the texture onto it. So it works. I can even use different textures. You can do multiple selection. Like you know from on Windows, it's the control key. On Mac, I think it's the option key or something. It's just when you hold this and you click it, you can see there's multiple sides now. You can clearly see they are a bit yellow, orangish tinted, so, and they are not. So these are the selected ones. And if you now drag your favorite texture onto there, you can see it textures all them at once. And you can also see, you can actually see the classic tiling effect, because you can actually see, wow, look at this. This clearly is a texture that's being tiled, while when we look up here where the textures, the full textures, actually, it's also tiled. It just doesn't look as bad because the edges of the textures are usually made so they transition seamlessly onto the other side. So you can kind of seamlessly texture them. However, down here on the sides, it starts with the texture, when we can see this is the selected side, and it starts painting the texture. Let me see if I get a bit better look. It starts painting the texture at the beginning of this edge, or maybe this one. I think it's this one. Don't quote me on that. And then it paints the texture. And eventually, this side, well, it's over. All the area is painted with the texture, and on the next side, it starts again fresh with the texture. It doesn't continue the texture from here. And this is one of the disadvantages when working with these geometry volumes, because they are impossible to properly texture, because this is also, they are not meant to. They are not meant to. These volumes are really only for quick prototyping or to block out your level. You know, blocking out your level is when you start a level design and you just actually, it's the name is the deal. You just put blocks in there, just squares. Like, I want a level, and I want a building here, and I want something else there, and I want that this building is a bit taller. So you're literally just putting blocks into there. And later on, either if you're the artist, you can take care of this itself, or if you have another colleague who's the artist. Anyways, these blocks will then later be replaced by the actual assets that then more and more will become your actual level. And you've also seen what I've done this when I pulled them out. And let me drag out another one. Let me drag out this cone. You see, they come out fully textured. And this is because the first time when I created our cylinder, I didn't have any material selected here. Let me reopen this folder. I don't have any material selected here. And if I now drag out one of these geometry boxes, since I don't have any material selected, it comes out completely untextured without any material. And then we can do what I just did here. We can manually drag our materials onto each side and give it the texture we want. Or if you say, nah, I want the whole cylinder. I know what texture I want. I want like this wonderful brick texture here. And then you select your material, and while this material is selected in the content browser, you drag out your geometry volume, and once you let go, it creates the volume complete, which with each and every side textured with the material you had selected. So let's, the 8 sides look quite well actually for a well. Let's just make this, do we make this a bit smaller? No, the texture is not really suited for larger objects, but I think I'm getting the point. So we actually do we make this? Now we're happy with the size. And we also activate the hollow now. And then we drag out a copy because I want to show something else just because it looks so neat. Then we deactivate the hollow and we make this rather thin because we just need a little plane and we put it like there. And now I'm pretty sure there's a water texture somewhere. Somewhere there's a neat water material. Ah, here, water lake. Let's try, I don't know, should we try the ocean or the lake? Let's try the ocean and see. Now our well doesn't only look like a well, now it really looks like a well because we got some water in there. We could just use the lake. Maybe it looks, well, whatever you like more. So this is basically how you block out and how you create your very first geometry if you're just starting out designing your level, or if you just want to try out things, or maybe there already is some sort of level, but you're a developer and you're creating some code that your artist will later on use to create some sort of asset. Like in our project that we're currently working on, Let Them Trade, we have game tiles. Because our game takes place in a hexagonal grid. So we got game tiles. And when I first created the code for these tiles to actually behave like they're supposed to, and for all the magic that happens in the background, so the tiles do what they're supposed to do, I needed some placeholders. Because the code, it worked with meshes. It disabled and enabled meshes. It spawned some meshes, not messages. The message about the meshes is mashed up or something like that. Like the whiskey mixer that gets a whiskey for the whiskey mixer that mixed the whiskey. Well, you get the point. So I needed some placeholder meshes that I could just throw out my code so it could do what it was supposed to do. I could try out if my code worked. And this is exactly what these things are pretty handy for us. So the disadvantage we just saw is they are very, very hard to decently texture because they are not supposed to be textures. This looks quite okay-ish now. This looks pretty okay, but especially when you start dragging around the vertices, because we also showed this last time. You can go into, let me select this one, and then you can go into brush editing. And now you have full control. This is the advantage. This is the nice thing about these brushes, because you can create your own geometry. These shapes, the box, the cone, the cylinder, or the stairs, or the sphere, whatever, they are just a starting point. And now you have full control. Like, I can select this face, and if I wait a sec, can I just move this? Yeah, this moves the whole thing. It didn't really. Okay, I hadn't select the face. I still had select the whole thing. Bereit geboren. Hi there. Greetings. So I can select the face of this. Gotta click multiple times because the first time it just selects the whole object and the second time it selects something. Eventually it notices you want to select the whole face, and then I can move this face, and you see everything else changes and adapts so that this change then works and is applied. I could also select this edge if I hit it, and I can just move this up, and this goes down to the individual vertex. So I can, for example, just grab this vertex and just pull that out a bit. Just this one single point, this one corner point, I can grab, and you see, it manipulates the whole geometry, and it adds faces, it adds edges, so I get exactly the geometry I want. But this is inherently untexturable. So if I now want where's my brick wall texture? If I now drag my brick wall texture onto this, you see this is all over the place. This is absolutely not how you would want it. These are horizontal, these are vertical, these are diagonal. And there's only very little you can do about this. One thing you can do, not sure if you can, I think you can do this phase-wise because you have these surface properties. And I hope you can see this through the selection, through the yellow selection. But you see, you can move it around. I hope you can see this properly through the selection. But if you click on these, or you can even type in your own numbers, you can move the texture. So you can try to align it in both directions, vertical and horizontally. You can even rotate it. So we could try to rotate this by like 45 degrees. Maybe it was the wrong 45. Oh, 90 degrees looks kind of okay. And then we can rotate this by 90 degrees. But it's still rotating the other one. Don't ask me why. Let's deselect everything and try. I just want to affect this one. Oh yeah, okay, now it worked. Somehow the selection got messed up. So this looks better than before. Especially this side, it aligns quite well to this one. This one, it looks better than before, but it's far from good. So this is the downside. This is one of the downsides when you're working with these volume brushes, these geometry things. You're quite flexible on how to create it, and you can go nuts and go wild into everything you want, and you can create your geometry with it. But there's no way of really properly texturing it, and because they are not meant to, they are not supposed to. But this is okay to get a rough idea. If you want to put a well like this into your level, it's okay to get a rough idea like, yeah, okay, this would actually work. This would look good if this would be a proper well, and then your artist can create one, and you can eventually delete this one and replace it with the proper asset. And as I mentioned before, sometimes because these are just volume brushes, and this is why you can edit them like this. They are volume brushes. But the things like back here, our chairs, for example, these are proper static meshes. This is what we call a static mesh. So what's a static mesh? A static mesh is basically a proper 3D object. Something you would import from your favorite 3D modeling tool, be it Blender, 3ds Max, or whatever you use to create your 3D models. And these are your proper 3D models that you will, in the end, in the production version of your game, that you will see and have and use to make up everything that looks like something. The disadvantage of meshes is, of course, you can't edit them in the Unreal Editor. You need your 3D graphics program to do this. So this is the reason why those volume brushes, why those are so nice for the coders, in my case, when I need some placeholders that I can work with to test my code, because my code needs meshes to do his thing with. Because as I just said, I'm spawning meshes, I'm moving them, I'm manipulating, I'm doing stuff with them. So I, as a coder, I don't need to use a 3D modeling program just to create my placeholders. I can create those placeholders just here directly in the Unreal Editor. Yeah, and create whatever I need or want. But again, those are not meshes, but we can create a mesh out of it, which is quite easy. Oh, and I totally forgot to show the subtraction thing. Remind me of that if I forget it again. But first, let me show you, because you can quite easily, you can select see, we have two of these volume brushes now. We have the one with our water puddle, and we have kind of the wall around it. So we can select them both. And then we should have an option somewhere here. And thank God I'm so well prepared that I totally know where it is. But we totally should have an option to convert those into a static mesh. Yeah, there it is. Clean German. No, it's not. Ha! This is something different. Some things are hiding behind these little arrows, and there we go. See, there it is. Let me revert this to original state. So you select your volume brushes you want to have, and then you scroll down to your I think it was the brush settings. See, I've done this 30 seconds ago and I forgot already. Scroll down to your brush settings and you have this little arrow here, show advanced, where you get more options. And you got quite a lot of buttons you can push there. And if you have just trying out an experimenting project like this one, just go nuts, try out all the buttons and see what they do. But the important button for us now is create static mesh. Because all it needs is one single, okay, it takes a bit more, it takes a few more mouse clicks. So we tell Unreal, okay, I got my volume brushes, they are floating around in the level, but I want to create a proper static mesh. And static meshes are assets that are stored on the hard drive. So we have to save it. And all we need to do is to select where we want it. And I just put this into my developer folder. If you wonder what is a developer folder, watch the VOD from last week. Because last week I explained in excruciating detail what the developer folders are, how they work, and how you can kind of somewhat replicate the behavior of developer folders if you are not in Unreal, if you're someplace else. So just go back and watch last week's episode. So I will just put this into my developer folder, and I will call this SM, which is shorthand for static mesh, because this is naming convention. We talked about this last year when we did our C++ stuff about Unreal. There's best practices, there's naming conventions and all sorts of stuff. So try to feel free to look at them. So this is basic naming conventions. Your static meshes usually start with SM, and we call this cool. Wow, what happened there? Why did I lose my focus on the text box? Cool well. So because this is my amazing well with the water puddle, create static mesh, and you can see the selection changes. When I select this now, I don't get all the faces and the vertices. I just get the outline around this thing, because now, and also I can't edit this anymore. You see, I still have I'm still in the brush editing mode. You can see when I click this one, but there's nothing anymore I can edit here, because Unreal saved this out as a proper static mesh, as an actual 3D model. So from now on, it behaves just like those chairs in the background or any other 3D model, any other static mesh you would have, because technically, from a technical point of view, there is absolutely no difference anymore between this and any other static mesh you would pull into your scene. So I can even delete this, and I can browse into my developer folder. And you can see I have this new asset here, which is my static mesh cool well, which is, well, a static mesh. So I can just drag the static mesh into my scene, and there it is. There is my well. And maybe this is a quite luxurious town. They got lots and lots of water. They got 2 wells. So I can add another one. So why would you want to do this? Because if you got your brush geometry and you're happy with that, why not keep using it as brushes? And there's quite a few reasons, because if you're writing code that deals with static meshes, this code actually needs static meshes. Or if you want to add this to an actor, because you can't really add your brush to an actor. Which we could maybe do is, this is something we're going to be taking a bit closer look later on, but we could create a blueprint and we could make this an actor. And we also, last time when we did the C++ stuff, we also took a look at what's actors, what's pawns, what's characters. We'll be talking a bit about this next week, I think. Just one second. Keep that lubrication going. So if you want to know about this, just check out the previous sessions we did. We already did go into some detail there. So let's create an actor, and now I got my, well, I didn't name this. I just, okay, let's fix this. This is not nice. Let's not call this new blueprint. Let's call this BP our test actor. All right, and now we can open this up. We can move the tab up there, and this is something. This is a condensed, a minimal view. If an actor or a blueprint, this is you can see this is the data only of a blueprint. If you want to add some more stuff, open the full blueprint editor. This is an empty blueprint. There's no code or anything defined in this blueprint besides the basic data the base class has. But we want to add something. So open the full editor, because if I now drag my new blueprint actor, if I drag my actor into my scene, you see there's nothing. There's this little ball, but this little ball is only visible in the editor to show you, hey, here is something. There's an actor here. There's an object that's sitting here, right here in your level. So if I go into play mode and I fly out our little room we built last week, you see this little ball is nowhere to be seen. This is only a hint. This helps you in the editor to see there is an object there. There's an actor hidden here that's lurking in the shadows of your level. Yeah. Yeah, so don't forget it. Maybe it needs some love. Because, of course, we haven't defined anything that could be shown here. It's like when you're gonna get a sheet of paper and the paper is empty, of course, because you haven't drawn anything onto it. Also, let me go out of brush edit mode for now. Back to select, so this window automatically closes. So let's get back to our actor. And one way is you got the Viewport tab. When you this is something we'll be taking a closer look at today. For now, let's go to the Viewport tab, because here you can define how your actor actually looks like. If you want your actor to show up in the scene, in the game, when the actor is present, you want it to be seen. This is where you define how it looks like and what you see when you see this actor. And as I've said quite a lot of times already, if you see something, it's usually a static mesh. So what we can do is we can say add component, and we add the static mesh component, I hope. Oh yeah, there it is. And we add a static mesh component because that's what we want. We want something, a 3D model, to be used in the scene when this actor is visible. So, and since we talked about all these things, these are static meshes, we add a static mesh component to it. And the static mesh component has an option right here, static mesh. And here we can select the static mesh we want this component actually to use to render the visuals of this actor. And there's quite a lot. This basically shows you all the meshes that are defined anywhere in your project, that it finds anywhere. So this is why naming conventions are so important, because you can use your name as filters. So I called mine SM Cool Well. Let me just search for well. And I can see here it just finds my static mesh Cool Well. I select this. And there we go. Now I got my well as the 3D model that's being used when this actor is in the scene. And of course you can add multiple of these. You can move them around. You can arrange them. And this is kind of, it's not really, but this is kind of a mini scene. And all the models and all the things you put in here are also put into your scene when the actor is. Let's save this, by the way. Oh, yeah. Already exists. Do I want to replace it? I don't know. I just created it. There's no harm in replacing this. So here we are again. So yeah, everything you put in here is used. This is whatever is used and shown to render, to display your actor. And you can see here it is. Let me delete this again. And you can see this is my actor. This is only the static mesh. I hope you can see this. We can try to magnify this a bit. This is my static mesh. We don't want to use this. We only want to use this actor. The actor I just created, and the actor that has this static mesh in its visuals. So when I now drag my actor into the scene, you see there is, in this case, my cool well, because this is what we defined for the visuals of this actor. And this works with static meshes. So this is one of the reasons why you need static meshes. Or again, if you're making code that's working with static meshes, the code is expecting a reference to a static mesh and not a reference to some volume. You can write, of course, you can write code that uses the volumes, but you don't want to, because there's two really, really big disadvantages in using those volumes, those geometry volumes. And the first one I just demonstrated and tried to explain is the texturing. There's no way, unless it's a flat square, it's almost impossible to properly texture them. But the other is performance. These things, those volume brushes, they are very, very expensive when it comes to performance, because there's a lot of calculations that have to be done, because they are not static meshes, they are volumes. And these volumes first have to be translated and done some magic with, so that the engine ends up with data it can pass to the graphics card, so the graphics card can then in the end render them. While static meshes, being proper 3D models, the engine can just grab the static mesh and, as it is, throw it at the graphics card, also take the material, all the textures that are defined for this. Oh, die Schläuche! Hey there! Einen wunderschönen guten Abend wünsche ich euch. A wonderful good evening. I wishes you. Schön, dass ihr hier slidet. Ja, das kommt davon, wenn man Deutsch und Englisch mischt. Sollte man nicht tun, ne? So we're stopping the mixing. Thanks for sliding in. A wonderful hello to all the fine people who are coming in here with the Indie-Strolche. And hi. we're doing some very, very low level, very, very beginner and very, very basic Unreal stuff, because I had been asked by a few people like, okay, all the stuff we did in the past, quite nice, but I've never used Unreal Engine before. How the heck do I get started with Unreal Engine when I've never ever started the Unreal Editor before? So this is exactly what we're doing right now. And I'm currently trying to explain the difference between volume brushes and static meshes, and why static meshes are our friend and volume brushes in some situations are as well, but in other are, well, not so much. And I was just talking about the performance hit when you use those volume brushes, and the reasons why you need or want a static mesh. But enough about me for a second. So I guess you've done some crazy coding stuff tonight, haven't you? Or have you done more like art, or I don't know, model design, character design? Do the characters now look at the walls they're walking around? Yeah, anyways, hi. Try to do some art. Well, this is the nice thing at art, because basically everything counts as art. If I collect enough forks and spoons in my kitchen sink, I could just say, wait, this is art, you know. This is a model I built. This is worth millions. You can't destroy this. Well, and eventually I put it in the dishwasher and everything vanishes. In that case, it was very artsy. Yeah, that sounds good. Being very artsy, that's always cool. Yeah. So we're trying to do some art as well. Coda art. Because another thing I was talking about, what these volume brushes are actually quite good for, is for placeholders, for good old coda art. You're the coder. You're making up some code that deals with your meshes and does stuff. I don't know. It spawns your game tiles or whatever. You have a wonderful way of coming up with your placeholders, your 3D coda art, if you want, to then just throw out your code and see if it works. Because we just took a look at how easy it is to convert your brushes into an actual proper static mesh. And this is the best thing on this is the water texture. I just love how even the default water texture looks like. It's one of the most easiest way to build yourself a Stargate. Just put a ring there, drop the water texture in the middle, and there you got it. There you got your activated and running Stargate. So we can do this with our lovely box as well. This is the box, the hollow box with 2 holes in it. See, and this brings me to something I promised you again to demonstrate, and I've forgotten 2 times now. So let's quickly do this. So let's move out a bit. So let's take the box, and we've seen if we take the cylinder and we tell the cylinder to be hollow, like so, we actually get this ring shape, this donut shaped thing, because it completely removes the top and the bottom. It kind of hollows it out. But if we tell our cube here we want it to be hollow, where's the hollow check mark? There. It looks like nothing happened. And that is because the cube actually really got hollowed out, but the top and the bottom didn't get removed. So now let's say we want, for whatever reason, in this case down here, we just wanted square holes for where a door goes and where a window could be. But let's say we want a cube, but we want a round hole right through it. So that's pretty easy, actually. You just take the cylinder again, and you make the cylinder an actual cylinder by giving it a few more sides. I think 36 worked rather well, but let's take 36. I mean, this is a good computer. It should do. And give this an outer radius of, I don't know, 50? Yeah, 50 looks good. We'll make this a bit taller so we can stick this right through our cube. And then see that we get this a bit more into the middle. Because, well, just because why not? So, like so. And now it's the additive and subtractive option that I promised you about an hour ago. I'd show you again how it works. Because at the moment, all these BSP, all those volume brushes, they are in brush type additive. Again, not sure if you can see this well enough in this stream, so I'm going to try to magnify this a bit. We got the brush type additive for both of them. And of course, this makes sense. So these brushes, they are added to the world because by default, our world is completely empty. An empty level actually is exactly that, completely empty. There have been older engines, and I think Unreal Engine 2 worked this way as well, where you started with a completely solid level and then you carved out everything you wanted and then maybe just put something in again. But in this case, in these days, you just have a completely empty level. There's nothing in there. So if your brush is added to the level, of course, it appears and all of a sudden it's there. So if for this brush, I now select subtractive, you will not be surprised what's going to be happening because, well, it's going to be subtracted from the world. So if there is something it can be subtracted from, like this cube, it will. And you can see I didn't really hit the middle there. It's a bit offset. The brush is still there. So even if we can't see this, and especially if I move this out, I have to keep track of my brush now, because if I now deselect it, it looks like it doesn't exist anymore. It looks like it's gone or it's invisible or it doesn't have any content. But it does, it's still there. It just gets subtracted from everything that is subtractable. You can't subtract this from a static mesh, for example. You can basically only subtract a brush from other brushes. So you can see if I move this in there, it just carves out the geometry of this brush from whatever else is there. And now I can try to put this properly in the middle. Yeah, and it's not. Cool. So let's move this a bit more like so. Well, okay. Yeah, let's say this is centered enough for our needs. So now we got a cube with a wonderful, perfectly round hole right in the middle through it. Because we set this to subtractor. And so you can really go wild and do whatever you want. And then in the end, we can select both of those brushes again. And we can go down here again, create a static mesh. And I again put this in my developer folder. And I call this cube with hole. Okay, just slamming enter doesn't work. You actually have to click the create static mesh button. And this is it. There we got our static mesh. I completely forgot to put any texture on it, but this was for demonstration purpose only anyways. So yeah, perfectly fine. I can delete this. And in my developer folder, I now have another static mesh that maybe I can also add to my actor. Again, this is my little blueprint actor I created a while ago, where I added this wonderful well that we also created, the static mesh that we also created using the volume brushes, and I can just add a second static mesh component, because I can basically add as many static mesh components as my computer has memory. I do not want this. For some reason, it now childed this static mesh below this one. I don't really want this. So I can attach this to the default scene root. Maybe you're okay with this. Maybe you actually want it. Again, you can completely go nuts. You can create the hierarchy here, whatever you want, however you see fit. So this is the empty static mesh, and there is my cube with hole. Look at that. And I can put this into the water. I can even scale this a bit. Shino! Hi! A wonderful evening to you. So scale this down a bit. And there's just a little hint. Don't do it don't do this. This will give you this will actually give you performance problems. This is actually quite bad for performance. Don't do this. And this isn't specifically an Unreal thing. This is actually a thing with most engines. They don't like if you have decimal values. They like it when they are nice and maybe even power of 2 integer values. That's what engines like. That's what computers like. That's what your graphics card likes. And we actually had this happen. We had quite a field of mesh of objects in there, of static meshes, and we had really horrible frame rate, like in the single digits. And then we switched it a bit around. We made the original mesh a bit smaller and changed the scale from 0 point something to 1, 2, or 4 times the original. So we actually scaled down the original mesh and then only scaled up and not down. And we had a huge performance improvement. We went from 10 frames to 45-ish or something. We had some more problems there, but that was definitely one. So yeah, but now for demonstration purpose, this is perfectly fine. But if you do this for production, if you have your actual meshes, try to make don't scale down, don't scale into decimal places. Try to keep these as full integers. Even this works. It has a negative effect on your performance. So now I added the second static mesh to my actor, and if I now save this, did I say save as? I used save as. I wanted to use save all. 10 FPS is more than fine. Would some German minister say? I don't know. No. I don't know. Not sure. Maybe I'm not getting a joke there. But no. Well, the problem is with German ministries, or whatever they are called. They have no idea what they are talking about when they are talking about frames per second. So don't listen to them. Don't listen to them. The slow internet connections. Yeah, but you're confusing me even more, because 10 frames per second has nothing to do with internet connections. Unless you're saying that they know so little about what they're talking about, they're measuring their internet speed in frames per second. Actually, yeah, I think they would do that. They would totally do that. I think when you're talking about frames per second, they might actually think you're talking about your internet connection. It's not so far off. Yeah, it's true. So when I now go back into our little test scene here, and I drag my little test actor back in here, you see, there's my cube with the hole. It's now part of my actor. And whenever I drag my actor into the scene, I put a new instance, it's there because, well, that's another mesh we created and we added. All right, so back to our little box that's supposed to be a room, maybe a room with a view. Let's see what we do there. And we'll take a short break. I will lubricate my throat a bit if you need to go places. This would be the perfect time to go there. And see you again in a few minutes. And what we're going to be doing after the break is we will convert this volume brush box into a static mesh, because now we know how we do that. And then we'll be creating a door mesh. And then we will take a look at how we can make the door actually swing open, because having a door is nice. Having a door that's always closed, not so much. Having a door that's always open, why having a door at all? So we'll create a door, and then we're gonna see how we're gonna open it. All right. Yeah, let me just find the proper button, and now it's time to go places. See you in a few minutes. Take care. All right, so let's dive back right into the action. I hope you're all well rested, been places, and with well lubricated throats. Cheers. So, first thing we want to do is to create a wonderful static mesh out of this box, because that's how we roll now. We know that we are supposed and want to use static meshes. So, well, that's what we do, because we know it's so super easy. We just hit the create static mesh button, put it somewhere, and we call this static mesh up our first room. Create static mesh. Okay, I hope there's an undo for this. Okay, I hope there's an undo for this, because you can see we lost our door or doorway and window. Can I actually undo this? Undo convert actors. Yes, okay. The reason is because this wall is still a composite wall. There's still multiple volumes involved in this, because if I only select my room, well, I only have that one hollow cube. But there's also, and I just need to see if I can actually select them, there's also the volume for our window. Because as we've just seen, okay, now there's all three of them. Because as we've seen, just seen again, we can, these are subtracted. These are two brushes that are in subtract mode. So they get removed from the wall. And now we can create a mesh out of this. And maybe I can just, can I override this? I don't know. Our first room. And there we go. Now I should have our first room mesh here. And I can drag this into the scene just once more. And for whatever reason... Oh wait, this is the first one. This is the messed up one. Okay, maybe it got a bit confused, or maybe I need to save. Yeah, let me save this. Save all. Oh, no, what's that? That is not something I want. I want save all. So, and if I now drag this in here, well, it still doesn't work. Okay. That's interesting, because this mesh has to come from somewhere. Where is that mesh located? Or maybe I need to refresh my browser here. I think I confused the engine a bit, because I saved my second attempt under the very same name. But I already had our first room here, the wrong version, the one where it's missing the door and the windows and everything, and they're not just on the other side, they're actually completely missing. So I wonder where I saved this one. Maybe I saved this, maybe by accident I saved this. Oh yeah, I said, okay, I see. Yeah, this is another one of these layer 8 problems. My second attempt of the room, I did not save into my developer folder. I saved it directly to the content folder, which for now is okay. So this is content we want to use, so it's perfectly fine to have it in the content folder. I was just showing how I could basically build a skyscraper, because since we have our little room with a view, now as a static mesh I can just pull this mesh right here into the world and move it around and basically build a skyscraper full of my little rooms. Quite nice. So let's try to build a door for this. First, let's see if we find a nice material that what would be a wooden door or something. This metal looks nice. Oh, there are even, and these are the default materials. These are the starter content materials, the materials that just come with the engine for you, for your first experimentations and tries and tryings and whatever. We are live. Yeah, because the preview works. All right. Because the session counter tells me I've been live for 0 hours, 0 minutes, and 0 seconds. So let's hope that just that display is broken. But the preview still works. So yeah, looking good. I trust you guys. I trust you. And when this team craps out the next time, I trust you to, again, just let me know in the chat so I actually know that I'm not live anymore. Because the problem is since the PC just froze up my preview here, it still showed everything on the monitor it was supposed to show. Well, except nothing moved anymore. So that might have been a dead giveaway, literally. So, anyways, let's see. Do we have wood floor walnut? Let's see. How does that look like? Can I have the preview, please? Okay, this is actually floor tiles, because I was thinking like we could use this for our door. Let me close this act again. So, well, I'd like to use something fancy like this one. Now let's just. There's several types of wood here. So we have this rather dark wood for our walls. So let's say we make the door in pine wood. That looks pretty neat. And we drag out a box, which is properly textured already. And now we only need to make it the right size, which I totally forgot which sizes we had. Let's see. I think we made this one 50, maybe. Let's see. Does that work? Oh yeah, this is cool. This is 150. And I think we made it. Wait, in the red axis is X. So in X, I think we made it 100 wide. Yeah, that looks pretty neat. Okay. And yeah, how thick do we want it? Which one is it? I think this one. 10? Is that cool? Yeah, this looks like a solid door, doesn't it? You can just place it in there like so. It doesn't perfectly fit for whatever reason. It's a bit offset, but this is okay for now. This for now, for just testing it out, this works. Yeah, this pretty much looks like a pretty rough door, like a pretty rough wooden door, like one you would see on a construction site. This is not a door you actually would find on a house or something. This looks more like a temporary door you would find on a construction site. So we need a door handle. Let's also give this a metal steel door handle, and the door handle will be a sphere. This looks more like something you would find in Disneyland. So, where is it? Is it that? What's the? Oh yeah, this is how many faces this thing has. I don't know, 8. Yeah, it only goes up to 5. It only goes up to 5. All right. Let's keep this at 4 because we are making this way smaller, like so. This is a pretty huge doorknob. So maybe actually make this 5 units. Yeah, that's okay. So let's position this. Okay, this looks neat. So this will be our door handle. Does this look okay? Yeah, this looks okay. So let's have a second one. Let's out drag this to the other side to make a copy of this and just have it stick into the door as well. Okay, so this will become our door mesh. So we select all the brushes we want to be part of our new mesh. Well, it's not that easy. Let's try it this way. Why doesn't it let me select? Why can't I select all of them meshes? I think this. I think no. Yeah. Now I got. Not sure why the brush 7 is up. Oh, because those are spheres, and it sorted them alphabetically. All right. So, create static mesh, and this will be a static mesh. Our first door. And I will actually put this into content. I will not put this into my developer folder. Let's put this into the content folder. And there it is. There it should be. Here's our doors. So should we need more doors like for above, for the other floors here, we can just move this around and have more doors. Just need to properly place them. Yes! A door high up where no one ever is going to be reaching it. But let's delete this again because, and also let's delete this door now. Because now we will be creating an actor for this. You might have seen if we just drag our static mesh somewhere into the scene, it will become a static mesh actor. You might see this here, there, static mesh actor, and this is actually what we need. There's it's performance stuff because how the engine handles things. If those are like if those are not simple actors, but for now, because you will see why we create a blueprint class. We make this a normal actor, and we will call this our door actor, and you will shortly see why I'm creating a separate actor for this. So open this up. Add the static mesh component like we've done before with our well. And just tell this, this is the actual door. And select the proper mesh, which is this one. Oh, no, it's not. This is a shiny door. This is a really nice door. But this is not our door. This is actually from the starter content. This is a proper static mesh of a proper door. Like, this is the one you would get from your artist when he starts creating the assets for your level. Now I deleted the whole component, so let's just re-add this. This is the door. But we're the ones just prototyping, placeholding. So here's our first door. This is our door. This is our placeholder door. That for some reason now completely has the metal. Okay, now we have a metal. I have no idea what happened there because here it's still. Here it's still showing the wood. And as you can see, the front is now also completely the metal texture. That's weird because I'm pretty sure when we created when we created the mesh, I am pretty sure that we had it, well, properly textured. But well, okay. For what I want to demonstrate now, this should be okay. So, well, yeah, we have a metal door, at least on the front and the back, because you can see here we still have our wood texture. Also, there's no way of changing this anymore, because since this is a static mesh by now, and this is the disadvantage of having of static meshes. You can't really change them. I could change out the material. I could change out the steel material for, like, I don't know, the rust material, but it changes the whole material. So everything that uses the material then uses the other one. So if I would give this the wood material again, also our doorknob would be wood. So yeah. Oh, gradient. Is this a nice gradient? This is transparent, right? So yeah, see, and this is one of the disadvantages. I'm not exactly sure what happened there. Maybe I dragged something. But yeah, you can see there's also things that can go wrong. If you create your meshes using those brushes. So the first thing I want to show you, first let's save this all. I'm not exactly sure. Maybe I actually hit the wrong button or something. But for now it's okay. I don't want to recreate the whole door. That's time we can put to better use. So let's drag this somewhere here and let's put our focus on it. Because what we want to do is we want to rotate the door. We just want to rotate it using code. Let me move this above the grid. So, and you can already see that the gizmo, which is not the little critter that you can't get wet and can't feed after midnight, but the thing with the little arrows, because we're in movement mode, it's the arrows. The gizmo, the handle, the pivot point. These handles, these gizmos are always placed at the pivot point of objects, of meshes. So if we rotate this, you see it's actually, I want to rotate the other axis like this one. You see, this is not really rotating around the axis we want. This is rotating around our outer doorknob. This is actually, at the moment it's rotating around the doorknob. I would have expected it to be even more weirder, but this is not the rotation we want. And there's a few ways to deal with it, and the easiest one is we just delete the mesh again and we go into our actor, because this little ball here, remember this little ball, it told us at the beginning when we didn't have any meshes here, it told us like, hey, here's an actor, here's an object, take care of it, it deserves love. But this is also the origin of this local 3D space of the actor, and the origin is the 0, 0, 0 coordinate of where something is. If I click on my mesh, you see we have the transform, and on the transform you also have a location. Let's set this to all zeros, and you can see the pivot point of our door is exactly where the white ball is. That shows us this is the origin. This is the x0, y0, z0 coordinate where everything originates. This is also the pivot point of our actor later on. If we put the actor into the scene, the pivot point will also be right here on this mark, on this ball, on the origin. So we can now align our door so it properly lines up with the pivot point that we actually want the door to use. So move it a bit out there and maybe a bit up. So we place the pivot point of our door right here, right down there. Can I, if I can get this a proper view, right here, right at where the origin of our actor is. And see, this is the snapping. We've talked about the snapping last week. It's currently set to 10 units. So I can't actually put this in the middle of the ball to have it exactly, to have this edge exactly at 0, 0, which is absolutely no problem, because I can just set the snapping to 5 and then, well, move it half of 10. But then I just put it back to 10, because personally I like the 10 unit snapping. That's quite okay. It works rather well for me. So here we have our metal door. And now if I save this and we go back into our scene, and now instead of the static mesh, I drag my door actor into the scene. And I'm still having the rotate tool selected. And if I now start rotating the door around the blue axis, because this is the one we want to rotate our door, you can see it swings open and shut like you'd expect from a door. So wonderful. Select the move tool, remove this one, and where is... Let me see if I can find our room. There it is. Here's our room with a view. And let's put the door into. So this is our door actor. Again, very important. We are using the door actor, not our static mesh. And I'll just slide the door in here. Interesting. It doesn't really snap. That's quite interesting. So let's... now it did snap. All right. And ignore the bot. I still need to remove that message, but I'm lazy, so this might take some time. So now we have our door, which is not rotated, which is at a neat position and fits perfectly into our doorway. And should we give this a rotation like 45 degrees, you can see it perfectly nice swings open like you would expect from a door. So this is one quite easy way, because everything that's in a scene, and we've talked about this during the last series, everything in a scene is an actor. Everything you put into your scene is at its heart an actor. So usually you want to create your actors for stuff, unless you really just want to have a static mesh that's pure decoration and you're not using it. You can just immediately drop this in. But this is a bit more advanced. We might be talking about this at a later date. For this door actor, it would actually not. It's not quite beneficial to actually having this in actor. This should be a static mesh actor, but then there's a few other things you have to take care of. So for now, since we only have a handful of actors, so we are not that performance. Performance isn't that much of a problem yet, because we're just trying out stuff. Performance is something you get at when you're a bit more into things. So for now we have our actor, and this is a neat way to, especially if you have multiple meshes. I mean, what we could have done is we could have made one mesh for the door itself and another mesh for the handles, and then we could have assembled them right here, and then they have a common pivot point, which is the origin of your actor visual. And yeah, well, now there we have it. Let's put this back to 0, because one thing, and there's a bit of time to at least get this started, and we'll be finishing off this next week before we then slide over into Unity, because after this little crash course of how to get started with Unreal at all, we'll be switching over to Unity, and There might be some pretty interesting stuff we have in the pipeline for this. Where it's not quite set in stone, but yeah, there's some cool stuff coming up. So we want to open this door. And now that you know, and we want to open this programmatically, like in code. So if I hit the play mode button now, if I go into play mode, and the door could still be moved a bit down, right? I want to see the door slowly swinging open. Oops. The escape key was the one I wanted. So there's a little gap. Let's try to fix that. Can we move it down? Oh, and then we have the gap up there. All right, so we have to set the snapping to 5 again, so we can move it halfway up, and it still doesn't fit. Okay. Oh, because I set the rotation snapping. Okay, of course I need to set the movement snapping to 5. And see, now it perfectly aligns. Now it perfectly lines up. Okay, so you got that set. You know, okay, I know how I can block out my levels. I know how I can prototype. I know how I can make my placeholders and get some own static meshes into the world that I can then work with. But now I actually want to do something, because a game not only is just static stuff and a default player controller that you can fly through the world, you actually want stuff to be happening. And you usually make stuff happening using code. You code stuff. And Unreal Engine has a very nice thing for people who have not that much experience with coding, or don't feel comfortable, or just don't want to. There's the blueprints. And blueprints are very, very powerful, because you can do everything with blueprints you can do with C++. If there's anything, there are only very few things you can't do. So you can do almost everything, besides maybe some super hardcore C++ magic or stuff. But you can do usually most of the usual stuff you can, or pretty much almost all of the usual stuff you can do with blueprints. So let's do this. So for now, we've been in the Viewport tab of our blueprint. This again, let me close this again. This is our blueprint. And just to make sure, let's see that we save all, that everything is current. And here we have our door blueprint, the one we just created. And I double click on this to open it. And so far we've been in the viewport view that gives us exactly that. That shows us everything that's visual that we put into here, because this is supposed to represent our actor visually in the world. So now we go over to event graph. And this is where things get really, really interesting, because this is where we will do the blueprint coding. And yes, for those who ask, in my opinion, you can call what you do in blueprints coding, because basically it's exactly that. It's just a different language. It's a language that's not written in lines and words. It's a language that's written with boxes and lines. So it's like comparing English with Egyptian hieroglyphs, only that this is not as complicated and nobody understands it like the Egyptian hieroglyphs. This is way more easy. And it also gives you a lot of help finding what you need or what you want. So what we want is, we want to swing the door. So we want to rotate the door. We want it to rotate. So what we want to do is, do we have a rotate here? If you click anywhere on this empty, on this blank field, anywhere where there's nothing, anywhere where there's place, just hit the right mouse button, and you get this selection box of all the things you can do now and call from here. And we want to do something with rotate. So let's see, what do we have? This might be a bit overwhelming if you're completely starting out, if you have no idea what you're doing. But then just Google your question. Just Google like rotate an object from blueprints, and you will find your answer. And the answer will actually be we can get the actor rotation. See? There's a get actor rotation. And for every get, there's also a set. And there's a set actor rotation. And what we want to do is we want to fetch the current rotation of this actor. Get actor rotation. Can I do a break up here already? Split, yeah, split struct pin. Okay. And then we want to add a value onto, and I have to see which axis this is. If I click the rotate, I click the door. It's the blue axis we want to rotate. And if you look at the transform inputs here, the blue axis is the Z axis. So we want to rotate the Z axis. So we want to add something onto the Z axis and then store this new value and then set the current rotation to this new value. So this is our actor rotation. This is where we get the current rotation of this actor. And we can just drag out from this return value pin. Just drag it out, have this line and let go wherever you want. And then you get a list of options. Again, make sure that you have the check mark at context sensitive set. Because this means that when I do this, when I drag this out and I don't plug it in, I could just plug this in here because this is accepting a rotation as an argument, and this is giving me a rotation. So I could just plug this right into there. Works. See, those two are connected. But this would now set the actor rotation to whatever is the current actor rotation. Pretty boring because nothing would happen. So let's break this again. And just let's drag this out and don't connect it to anything. Just let go anywhere. And when you have the checkmark at context sensitive set, it shows you all the options you have, everything you can do now with this value. Let's see if there's an add. There's an array add. Actually, I want to show if because what we're getting here, we're getting a value of the type rotator. I'm not sure if you can read this in its viewing. So see, return value is of the type rotator. This is just a special variable type, like you have your integer variables, you have your string variable, whatever. And this is just a rotator variable because there's, well, a rotation stored in this. And I want to see if there's an add for rotator, but there's not. Because I would like to add two rotators onto each other, which does not seem to be a function that exists at local. Add the rotation of this component. Yeah, this would work. Yeah, but nah, this is not what I want to show you. Okay, so what we can do is we can right click and say split struct split struct pin. So, and now it splits up the rotator because the rotation basically is an X value, a Y value, and a Z value. Or in rotational speak, roll, pitch, and yaw. Pretty common for every one of you who've flown something with spaceships or airplanes or anything. You got your roll, you got your pitch, and you got your yaw, which is just fancy names for X, Y, and Z axis. And we said we want to add to the z-axis. So we can drag this out because now this is split up. This is the rotator split up into the three separate values it consists of. And those are just simple float values. You can see, let me zoom in again. If I hover over this, it tells me, yeah, return value z, yaw, float. All right. And floats, we can do something with floats because there should be an add and there should be a float plus float. Yeah, there it is. See? Let me zoom in again. Here is math, float value, one float plus another float. Perfect. That's exactly what we want. And just because we have no idea of how fast things goes, there's a 1 in here. It just puts in a default value of 1, which is perfectly fine. Let's stick with that for now. We can still change this because we have no idea how fast is that. Is that like super fast? Is that like super slow? Who would know? You know? So now we have these three values. They are unchanged. We didn't do anything with that. We have the Z value, which we added 1 to. So the output here. So in blueprints, you might have already guessed, these nodes, those squares with lots of stuff in them, they are called nodes. And those are, if you're at least a bit familiar with classic coding, that's basically one line of code. That's a function you call, it's a variable value you set, or whatever. Here on the left is inputs. So if you're a bit familiar with classic coding, this is the parameters this function takes. So you call set actor rotation, and that wants to know something from you. That wants to know this and this and this. And it returns you something. It gives you something back, and those are the pins on the right side. So on the left, that's everything you pour in, you give into the function, so it knows what you want to do. So it can do what it's supposed to do, so it knows what you want it to do. And the pins on the right are everything that's coming out again. So in this case, we have we will be, the self might already be okay. It will know a target. So who is it? You want to get an actor rotation, but from who? From which actor? So if you have a reference to a different actor, you can pass this in here as input. So get actor rotation knows from which actor you want to get the current rotation. But the default value of self should be perfectly fine because we actually want to get the rotation of this actor we're currently doing this blueprint for. So on the right side are the outputs. This is everything we get out of it. This is what it tells us. Yeah, this is this, and this is that. There's one slight thing more, which is these white triangle-ish thingies. We'll be coming to those in a minute. You see this one doesn't have one, which might be a bit confusing at first, but, well, it's just like that. It's because, spoiler alert, this is not really a function that's called. That's more like a value you access, and this is an actual function. And should you ever pass these into a function that actually accepts input and does something, it knows, oh wait, you want to pull it out of this value. It pulls information out of this value. So this is kind of a property or a variable, and this is an actual method you call, for those of you who are already familiar with other coding languages. For those of you who are not, this is just a value you access. This is nothing you can call. This doesn't have actual logic or code behind it that runs when you call it, because you can't call it. This is just a value. Like a sheet of paper that's sitting on your table and there's a number written on it. This is this. This is a method. This is something that actually does something. This might be like the shredder, the document shredder beside your desk. That does something, that destroys data. So you could take this value, the piece of paper, and throw it into the shredder, which would kind of be calling a delete function or something. And that actively does something with the value you've just provided it. So that's just the difference between those and those. Oh, and Cyborg Wolf gifted so many subs, Cyborg Wolf. Many, many thanks for all those sub gifts. You're crazy. And hi, throat needs lubrication. Which is empty. My wonderful devcom mug. Can I have this in yeah, so everyone can see it. It's empty now. But that's not a problem because I am well prepared, so I still have a glass of throat lubricant, which is iced tea, by the way, today. Today is not coffee. It's not coffee. Today's actually iced tea. Yeah, works quite well as throat lubricant. So at least there, I'm prepared. So, we have these three values. We have those three, and we have the new one where we added something onto it. Now we need a new rotation. And let's see if we have something that calls make rotator. Make rotation from, let me see if that is, yeah. That's not what we need. Because for those more complex values, like the rotation, that consists of multiple different thingies, usually you have a make function. I think there's even stuff like make int. You can just create a new value, a value of any type. You can create it, and often you also get the option of passing stuff into it that's used to create the new value. Like when you create a vector or a rotator, I want to pass in the three floats. That then should be by default the value. So let's see if we actually find make rotator. I mean, there it is already. Look at that. Here, make rotator. This is exactly what we want. It takes, also these are green. So if you can see this, these values are green knobs, and it tells us, yeah, those are flotation values. And these are green, and they are also float values, and they are on the left. So that's stuff we can give into this. And this gives us a rotator, which is exactly what we need in here. So we can use this make rotator node to create the rotator we need up here from the three float values we have, which also might work if I just drag one of the float values into the, okay, no, it just tells me it's not compatible, because sometimes it creates a conversion node automatically. Like say we have a make integer, make literal integer, and this also has an input and returns an output from an integer. If I now drag this float value into this integer input, you see it would, if I would want to drag this into new rotation, it just tells me, nah, you can't do this. Stop sign, this will not work. But in this case, it would actually work. And as you can see, it added another node automatically in between that creates an integer by some magic from my float value. And this way, it's truncate. You can also, if you have, you can even take this a step further. Let's say we have a string, because make literal string, there it is. Because we are I don't know, we want to have some text, some string value that later on we want to output somewhere. I can drag the integer into the string input which will work, and it will automatically create a conversion node that converts my integer into the string value, or the very same if I drag... Oh, okay, I just move them around. Okay, see. If I drag this float value into the string input, it will add a conversion node in between. It doesn't always work. Sometimes it just doesn't know what to automatically add. Like when I pull this float into the rotation, it doesn't work. So this is why sometimes we have just to find those make functions ourselves. This does exactly what we want. This is the make rotator. So I can just plug the X and the Y value in there because we don't want to change them. I can plug my added up value into the Z value, and then I can drag the return value, the rotator that this node creates from these values, into this rotation pin, and see to line them up so it looks neat and tidy. Oh, by the way, last week we also discussed how you can customize the layout of the editor to better suit your needs. This also works for the blueprint editor. You can move these things around. You can move the details to some other place and resize them and do all sorts of stuff. Yeah, of course, this is customizable in the very same way, but the default layout here works quite more well than the default layout for the main editor window. For my actual work, I do have, I did change the layout a bit to have more space for the actual blueprint area, but this is completely up to you. I just wanted to mention that, of course, you can customize the layout everywhere in the editor, wherever you like. So now we have the function setRotator action that pulls the value that it's supposed to set from our make function that creates a new rotator value that again pulls its value from either directly the getEditor rotation value or the new value that we used by addition here. Which looks better, that or that? I think that looks better. But this hasn't been called yet because these white triangle thingies that I mentioned before, those are the execution pins, the execution lines. Those methods that, well, because again, those are just values. You can't call or execute them. And those are those that have these triangular inputs and outputs. Those are the functions, the methods you can actually call and execute. So you need to drag a white execution line into this left input pin. So this gets executed whenever an execution order from that line comes in. And also once this is done, when this is done doing whatever it's doing, it will trigger the next execution with its execution output pin. So we have to get an execution order from somewhere, and we have this event tick. And this event tick is quite a special function, quite a special method. And that is called every frame. Every frame the engine renders, this is called and gives us an execution pin. So I just drag this in here and again line this up so it's a bit more neat and tidy because that's how I roll. So with each and every frame, event tick is called by the engine, which will then initiate this execution line here, which goes directly into setActor rotation. That does whatever it does. And then calls the next function that's connected to its execution output pin. Since there's nothing connected there, nothing will be called. So our setActor rotation will now be called once a frame, which every frame the engine renders, this will be called. setting the rotation to our new value because we added one to the yaw or the z-axis. Let's try this. To try this, you have to compile your blueprint and compiling. Are we in C-land? This sounds complicated. No, it's super easy. There's just this little dirt. It needs to be recompiled. There's this compile button. You just hit it. Just hit the compile button and you're done. While you're at it, hit the save button as well because, well, better safe than sorry. If your computer crashes, you at least don't lose all your changes. So usually for me, it's just when I changed something here, when I changed or switched things around, compile, save, and that's it. I just hit both of them just to make sure. Now, when we go into play mode, oh, you see the door is opening, but it's not only opening. First off, the speed is kind of okay. And let me see if I can... Let me see if that works or if I disable... Oh, okay, I didn't disable this. Okay. The Unreal Editor by default has the habit to... because the Unreal Editor uses quite a lot of resources from your computer system. So the Unreal Editor by default thinks when it loses focus, when you Alt-Tab out of the Unreal Editor into another program, by default, but you can disable this, but by default, the Unreal Editor thinks, okay, you want to do other things with your computer now than to tinker around with me. So it reduces the frame rate to 2 frames, 5 frames per second. Jesus Christ, what's up today? Sorry. Sorry. Bear with me, I'm back. So it significantly reduces the frame rate. There's not much on the GPU we can see now because it doesn't use the GPU much at the moment. But you can see the door. The door is all of a sudden very, very slow. And when I go back into the editor, the door becomes quite fast again. And if I go out of the editor, and the editor reduces the frame rate to save resources and to give you resources for using other programs, look at the door. Wait, we can't even... I think it's a bit better if I actually... I need to hit stop here. Where is the stats? Because I want to see the FPS. Oh, yeah. Neat. I have no idea why this is running at 120 FPS, since this is a 60 frames per second display. No idea how it does the 120 frames, but, well, this might be just a weird thing of the remote solution I'm currently using here. So you see, right now it's running at 120 FPS. And when I Alt-Tab into something else, like Task Manager, great. The frame rate display disappears. Oh, come on. Seriously? Okay, in play mode it stays. It only vanishes when you're in the editor mode. So, look at this. The door is moving quite fast. And I hope you can see this. Fast door, 120 frames per second. When I Alt-Tab out now, out of the editor, the frame rate goes down to about 3 frames per second because, again, this is just because the editor tries to conserve resources, but it's perfect for demonstrating what I'm going to be getting at. Because this is one of the most common mistakes people make. And not even if you're new, not even if you're a starter, you're just starting out. Not only newbies or beginners make this mistake. Even people who make games like Fallout 76 still make this mistake because it's quite easy to make. Because see, our door now with 3 frames instead of 120, our door is like super slow. And of course it is, because we add 1 unit of rotation per frame to our door. So that means if we have 120 frames per second, we add 120 units of rotation per second. Since we add 1 per frame, 120 frames per second, so we add 120 units of rotation per second to our door. Now that we are only running at 3 frames per second, well, I think you guessed it. We're only adding 3 units of rotation per second to our door, which is way less than 120. And this is the reason why all of a sudden our door is so slow. So our animation, our game stuff, our game behavior is directly tied to our frame rate. And that's bad. That's something you don't want. Because even if you're at a lower frame rate, and the animation might look not so good because it has less frames, you still want the speed of the door to be the same. So how do we achieve this? And this is actually very, very easy. Because pretty much every engine that has something like this event tick. In Unity, for example, it's the update function. And in about 2 weeks, we start talking about Unity. So I'll also show you. I will show you the exactly same thing in how to do it in Unity and how things in Unity are called, because basically just the naming is different. It works very much the same. So everything that has such a tick or update function, you see, we also have this output. It gives us delta seconds. And this is one of the most important values you will ever have in your game. Because this delta seconds value is the time in milliseconds since the last frame. So if we are running at 120 frames per second, this will be quite little actually. I think it will be around 15 milliseconds or something. Don't quote me on that. This is just an educated guess. I think when you're running at 120 frames per second, this is around 15 milliseconds. So this is the time that passed since basically this has been called the last time. Since this is called every frame, this delta seconds tells you how long ago the last time was. So how much time has passed since the last frame, since this has been called the last time. So that means when we're running at 3 frames per second, this will be something like 330 milliseconds. Or 333.334 or something. You get the point. This will be something above 300 milliseconds. Because you're only rendering 3 frames a second. So the time between each frame is the third of a second, which is roughly 333.334 milliseconds. Unless when you're rendering 120 frames per second, it's only a 120th of a second. And this is why this value is so important. This tells you how much time in milliseconds or the fraction of a second since the last frame. And what we can do now is, now it's easier when I drag this. How do I? Okay, let's disconnect this. Let's disconnect these two. This is, or actually no, we don't have. No, we don't have to disconnect this. Because we want to add something to our Z value. Let me just quickly find the float times float. So this is an addition node. This adds 2 values. And at the moment we have fixed our one unit per add that's in there. But that doesn't work. So let's put this 1 into this multiplication box. This is a node that multiplies 2 float values with each other. And we just move the 1 we've just hard-coded into this addition node. Let's move this into this multiplication node and replace our hard-coded whatever we add to the rotation by the result of this multiplication. And now I hear you asking, but you need at least 2 numbers to multiplicate. And you're absolutely right. The second number is our delta seconds. Or let it be the first. Order doesn't matter. It's multiplication. You can switch them around. So now we multiply whatever we want to add onto our value. We multiply this by the time since, or the fraction of seconds since the last frame. So if we have 1 frame per second, we are rendering 1 frame every second. This will be a straight 1. So our value will not change. If we have lots and lots and lots of frames per second, the time between each frame is quite low, which means the delta second value will also get low. So we are multiplying our value with a lower value, which yields us, as a result, a quite low value. So that means that the more frames we have, the less we actually add to our value. Which in the end means that after a second, we've added the very same amount. Because if we add larger numbers a few times, or very, very tiny numbers a lot of times, in the end, the end result is the same. And this is the way how you decouple, how you get away from this being locked to the frame rate. So I know the 1 is a bit less. Let's put a 10 in there and just let's see what happens now. So compile and save. Go back here, go into play mode, and you can see it's quite slow, but we can change this. We can just add the number. We can just change the number. We can let's put a 20 in there. And again, after every change, compile and save. Go back there and start. Yeah, that's a nice speed, right? That's a nice speed. So zoom in and enhance so you can see the frame rate and the door. Now we are running at 120 frames, and this is the speed the door now moves at. Now I'll tap into my task manager. We're now at 3 frames per second, and you can see the door, it makes way larger steps. The overall speed is the same. If I would measure the time the door takes for 1 complete revolution, it would be the same as now. You see, the door, it does not speed up or slow down. Just the movement with more frames is way more smoother compared with when I have fewer frames. You see, it looks like 3 frames per second. The door, it stands still for quite a while, and then it moves quite a bit. And so the overall speed stays the same. And this is the magic of how you get your code not being dependent on the frame rate. If you do something each and every frame multiplied by the delta seconds, so to put it into one very simple sentence, multiplying with the delta seconds scales your value that you are dealing with, no matter if you're multiplying, adding, or I don't know what magic you do with your numbers. But you scale this number to your frame rate. So your effective speed is always the same. So you could say, in a way you could say that, what happened now? Wrong buttons happened. All right. What you could say is, this value I'm entering here is my amount or my value per second. So in this case, this is basically, I'm adding 20 units of rotation per second. Because no matter what the frame rate is, since I'm multiplying by the time that went by since the last frame, when I'm doing this for 1 second, the sum of this is 20. I hope this makes sense. If this wasn't, if this is still totally unclear, just let me know, and I will try to explain this a bit more better next week. But yeah, basically, by multiplying with the delta seconds, you're scaling your number to this number per second. I'm adding 20 units. I'm not just adding 20 units per frame, which then gives me completely different speeds at different frame rates, but I'm adding 20 units per second. So the speed always stays the same, just the animation isn't smooth enough when I'm having fewer frames. But when I have enough frames, then yeah, my door opens and swings around, looks nicely. It's still a bit weird because the door goes in circles. Next week, and this basically brings us not only to Unreal Basics, but also to the basic end of this basic evening. We'll be doing a bit more in the blueprints and see that we can actually have the door only move, I don't know, like 90 degrees or something. Just have the door open up to like there, and then just standing still. And then sitting there because it's open and not clipping through the wall and everything. Because that'd be another Fallout 76 thing that we don't want to do. And depending on how good we go, we might also add a trigger that the door initially just stays still. It doesn't do anything, and once we hit the trigger, it starts opening. But I don't know. Let's see if we have enough time for this. There's a few other things I want to look at you next week. So ja, so for next week, Nico, einen wunderschönen guten Abend. A wonderful good evening I wish you to have. Hi there. I'm doing fine, and another thing I'm doing is moving onto my couch because there's still some Netflix stuff. I recently rediscovered Magic for me. Unfortunately, they only got 2 seasons of this Magic show I'm currently watching. So I need to find the rest on YouTube. Which, fortunately, even though piece by piece, is officially available. So just need to scroll that. Yeah, next week, we'll be doing a bit more blueprints and see how we can make the door behave a bit more realistic, because that looks not so bad, but it should eventually stop moving and stuff. So we'll be looking at this and a few more other things. Next week will also, at least for now, be the last evening we're looking at Unreal. So if you have any questions left in regards to Unreal, ask them within the next week. So I can try to cover and answer them next week when we're doing the last bit of Unreal. The last bit of this basic 101, how to get started with it at all. Because the week after, we'll be starting looking a bit into Unity. And we'll basically start off the same way like we did now. We're just opening up Unity for the first time and look around. How does the editor work? What's the editor? How do we do stuff in Unity? Of course, we can't create our own static meshes. That is something that's missing. Maybe there's a plugin for that. I don't know. But out of the box, there's no way of adding geometry and making it into meshes. You still have the ability, of course, in Unity to add some basic geometry. You have cubes and spheres that are already 3D models, 3D meshes. We'll be looking at this. We'll be checking out how to maybe also get a door moving. That in Unity we have to do with code, but it's C#, and C# is also super beginner friendly. Yeah. But next week we'll be closing off with our little Unreal 101. And let me just find a nice spot where I can see our little skyscraper we built here, including the door. Yeah, I think this looks nice, doesn't it? That looks okay. That looks good. So, file, save all. You wonderful people out there, have a good night. See you next week. Bye-bye. Take care. And let me see if I find the right button. I think it's that one. See you around. Oh, also, if you have questions, you can, of course, ask in the... wait, let me... Need to get my mouse out of here. I think it was... social. Yeah. If you haven't already, join the devcom Discord, because you can ask all your questions there as well. You can also use the hashtag #AskDevComTutorials on Twitter if you like, or just if you're watching this on YouTube later on, just drop stuff down in the comments. I will check to find them. Oh, and you're nuking me so hard. Cheers, my friend. A wonderful evening to you. Your timing is perfect, because this is iced tea, by the way. This is not whatever you think this might be. This is, I promise you, this is just iced tea. And for all of those who either also have iced tea or something else, enjoy your evening. And yeah, I already said it, but it's like 2 minutes ago already. So I say it again. See you around. Thanks for sticking with me, and